Hello, everyone. My name's Louis. I'm part of the release engineering team at Rocky Linux, and so I don't, my when I made this presentation, the whole goal was to talk about the pain of bootstrapping and doing things, but it's not so much about a technical, not just about the technicals, but it's also about you have to tell a story, and because sometimes telling the story is what makes things more interesting and sometimes funny depending on your perspective and all that, because we all live in this weird tech world, and we're always trying to do stuff. And so um so today I present architecture bootstrapping for RISC-V, our RISC-V enterprise Linux story. Let's see. So a little bit about me. First, I'm gonna just say, like, I learned a little bit of Korean, so like a long time ago, so some of my translations might be wrong, so I apologize for that. But so anyway, about me, Louis Abel. I'm release engineering lead for Rocky Linux. I oversee a lot of the development and basically how it looks, and also vice chair on the RESF board for our foundation. For my day job, I do infrastructure and identity management, and that's it's just my day job. And then for the RESF, I do infrastructure, and of course I build Rocky Linux. And then I got other hobbies too. So I do music. Of course I do some gaming, and I do a little bit of cosplaying too. So if anyone wants to see pictures of me all dressed up, I can provide those too. So, but yeah. So chapter 1, context. So we got to talk a little bit about got to set the stage a little bit, right? So there's this concept of primary and secondary architectures. So a primary architecture is typically something that's like supported basically by default, like immediately out of the gate. And if something fails with one of them, everything else fails, right? And that means the success of all of these architectures relies on one another. So think like x86, that could be Intel AMD, ARM, AR64, our PowerPC, and our Z systems, right? All four of those have to pass, right? So because we maintain them all, right? Secondary architectures, it's not directly supported by my team, but we still build it and we still technically maintain it. But if something fails there, it's not a big deal. Like, it's not going to affect anything else. And the success of it relies on not just my team, but also others in the project that, have an interest in this architecture, which we actually happen to have quite a few interested parties that are doing interesting stuff. So, and of course, yeah, asking for help is encouraged, right? So RISC-V, for those who don't know, it's the 5th version of the RISC architecture, which I believe it stands for Reduced Instruction Set. I forget what the C is. I'm like blanking, but it's an open standard instruction set, and it's royalty free, and the whole point of it was to be usable, deployable without any royalties and all that. And I kind of like that because it allows people to be a little bit more cavalier and a little bit more open on making interesting hardware, right? And some of the important things for it comes down to scalability. So it's meant to be extensible, accommodate a wide range of applications. And because there's a lack of license feeds, like with the ARM architecture, it allows innovators to come right in and not run into any financial burdens, right? And the reason why it's important for this project in particular, especially from my point of view, it generally gives more options to our users. So that could be designers, tinkerers, and I'm one of those tinkerers. And then there's the IoT capabilities, or the Internet of Things, right? I'm assuming that's still a thing. But there's also interest from some of our sponsors that we're really looking forward to this. Energy efficiency, like one of my boards only like takes like 8 watts to run. Like it's like kind of a no-brainer. And then plus there's that potential for when 11 comes out, it'll probably be a lot more official right around then. That'll be probably 2 or 3 years from now, hopefully. So for Rocky Linux 10, we released it alongside of our primary architectures, which we had quite a few people who didn't think this was going to actually happen, but I strived to make sure that this was going to happen. And it was a very long process, which I'll talk about here soon, but we support the Vision 5.2s. You can usually buy those pretty easily. And then for 10.1, we're going to support the Hi5 Premier P550. And then our special interest group, they're currently building working on kernels and stuff for other boards, which I don't have my hands in. I don't want to touch it. I'm going to let our community handle the fun, the more interesting stuff, right? So start the machine, and this is where everything gets started, right? Like how I got everything going, how I got everything moving. And the first thing I'm going to preface this with is that there is always a better way, right? So, but first, the prerequisites to get this whole thing going, right, required no Arch packages, which is, you can have the package, it can be installed to any architecture. I had to have a Bootstrap repository. I had to have a bunch of Rocky related packages. I had to have macro packages. And then I also needed a Fedora Linux RISC-V repository to use. And there was one available, thankfully. And then I had to have a disk setup that did not mess with the SD cards on my Vision 5s. And then, of course, a working mock configuration. And for those who don't know what mock is, it helps you build RPM packages in a clean, reproducible manner. So we're going to talk about iSCSI architecture the wrong way, because I did things the wrong way the first time, right? So I had storage. So it's like, okay, you have some storage you can use, right? Good, right? And I had about, at the time, I had like 4 terabytes worth. So it's like, okay, good. I got storage. Bad, it's on my router box, and one of the drives is dying. And I didn't know this until probably like a week into starting this. Good. You have a 4 gig uplink to your network. I had like a bunch of Ethernet cables into my switch, which was okay. Also good, I have VLANs, so I could separate the traffic. I didn't create a separate VLAN for the storage. And even worse, I had my iSCSI storage running on the same link as everything else. So that basically meant that as things were building, if there was heavy writes, it would actually throttle my internet connection. And like it was not good. Like I couldn't stream, I couldn't do things at certain moments. It was horrible. This is basically what it looked like. Very very not good, right? So all my builders, VLAN 2000, like, okay, cool. But all the storage was actually right here. So you can kind of see like how bad this looks. So after about like a couple of months, I decided, okay, I can finally fix this, right? So I decided to do it the right way. So made sure I had a dedicated VLAN, make sure I had 10 gig links for my switches, my storage, everything else, dedicated ports for my builders, and then everything else for the most part was fine. And so these are just kind of screenshots of like what my storage looked like on the actual storage box. Nothing too crazy. It's like, okay, well, I had plenty of storage. like I said, I did iSCSI. Again, it's not super impressive. It's just, stuff. And basically, I gave every builder about 110 gigs because they don't really need much. They just need enough to download the source and do the build and then transfer. Like that. That's all they really needed, right? So, and in my opinion, this looks a lot better. This one looks a lot better. So you can kind of see the storage all on the left side and it's staying away from the right side. So life is okay, in my opinion. So the moral of that story is don't start the longest running build as your first package on the worst architecture you could come up with. Basically, I built GCC first. GCC is the primary C compiler, right? That took 7 days to build. So the fact that it took 7 days, you can imagine during heavy writes, like how bad this affected everything in my house when it came to streaming, to doing, even doing my normal job. Like there were some days, one of the days I actually had to go to like a Starbucks to actually work because my internet connection was just it was bad. Let's just put it. This is how I felt. Just like I just was so stressed out. I'm like, I can't do this no more. But I wasn't gonna stop it, right? I was gonna let it go. And the reason why I say at least it's not SSHFS is because we actually use SSHFS for very specific things for Rocky Linux 10 when we're doing like our images, our containers, our ISOs and stuff. So we have to use this, and it is so slow. It is so horribly slow. So let's talk about crippling dependencies. So this is where the pain really is, right? So generally, when we like bootstrap something or we're getting ready for the next release or something, if we have to, there's usually like an order in which we have to kind of pay attention to, right? And so it always starts with GCC, then it goes to glibc, and then we have Anabin, all those, and Anabin and friends. Then we have OpenSSL, Golang, Perl, the kernel, LLVM, Rust, base libraries. This is very important because if you don't do it in this order, you run into a lot of, let's just say you run into a lot of problems. A lot of problems that like will just, you'll get so tunnel visioned on something and not realize, oh, it's because I did something in the wrong order, and then you just have to redo everything sometimes. So when we were bootstrapping Rocky Linux 8 and we had to do the 32-bit packages, this was like part of that pain because there were some things I did in the wrong order, which required me literally to start completely over. And I was essentially trying to avoid this for RISC-V. And thankfully I did, but at the cost of a lot of time, right? And so I always ask myself, okay, why do bad things happen to good IT people? And I ask myself that every time I'm working on stuff, right? So if we go back and think about the GCC, the glibc, all that, it's like, okay, we have to think of that order every single time. We have to check for packages that might have been rebased, because when I was basing everything off of Fedora, like, okay, what's the difference between that Fedora release and what CentOS Stream 10 was doing? What were the differences? And there were actually some clear differences. There was actually some things that were like newer in Fedora or newer in Stream. And it kind of made things a bit difficult to kind of work with. But once I identified those differences, it made things easier to figure out, okay, how do I got to build these things, right? And sometimes there's like new dependencies, and sometimes there's things that Stream had that Fedora doesn't, and it just, then you have to kind of like deal with that. But thankfully it's not too bad. So LLVM, this one was a huge sore spot for me, right? I basically spent 10 days trying to build this thing. And LLVM isn't just one package. Like it's a whole host of stuff, right? There's LLVM, there's Clang, there's some libraries like libomp, LLDB, stuff like that. And the problem is like that has an order of its own. And LLVM and Clang, they require themselves to build. Chicken and egg problem, right? And what would happen is I would get the first few things done, and then all of a sudden everything would fail. And I would always run into the same problem, which is I would be missing symbols. For those who are programmers, I'm sure you probably understand the whole concept of missing symbols. This is essentially what I was always running into. And what I had learned is that in Fedora, they turn everything on. And Enterprise Linux, they don't. They turn a lot of stuff off, right? Where everything is default off, and then they turn like some switches on, right? Or they turn a couple of knobs, right? So this is like what I mean. So like in the spec file, you can actually see this. You can actually see like, oh, for like RHEL, right? Like, okay, we x86, AMD, power, bunch of other stuff, right? Okay, cool. But for everyone else, like Fedora, they turn everything on. And this is a problem because eventually the builds are like, oh, well, I really, 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 really need these symbols. And I say, no, you don't. You only need these. But the software was disagreeing with me on this, right? That's essentially how I felt for the whole 10 days, because I'm like, okay, well, how do I reconcile this, right? And so I managed to figure it out after about 10 days. This was the order. I had to use GCC to bootstrap this. Okay, cool. But I had to do it in this order: LLVM, LLD, then Clang, stop, and then start the process over to use itself. And it was good. Life was okay. And all I had to change was this. I just had to change this tool chain from Clang to GCC. And once I noticed that, I was quite I was thrilled, but also a bit upset. I bring up Rust because Rust was the easiest thing I ever built out of all of this. I just had to get LLVM done and then build Rust. Life was good. I bring up System D because because binutils, it had like a weird dependency on a newer binutils that CentOS Stream 10 didn't have. So I had to like do some workarounds for that. So here's another source of pain, right? Patching things to make it work, right? Some packages never built because they didn't have the support. Some packages were a version behind the one that had the support. Some packages supported it but didn't have it in there, like Java. glibc, for example, would be like, oh, hey, yeah, we have these unexpected files. And so I would have to like go and fix that. I would have to patch binutils to get the kernel to build. And that took me a few days to realize that. And then some of our configs, I had to do some heavy lifting and changes. And then LTO, that slowed things down and just outright broke stuff. Horrible experience. But we had to turn it back on eventually. This is how I felt every time. I just wanted to chuck my computer out the window every single time. So here is the fun part. I finally had about 95% of it done. And I was like thinking, okay, I want to actually see if I can build an image and get it to boot. And I'm not going to go over this whole screenshot, but this is essentially what I had sent my alternative architectures folks, like, hey, this is what I did to make this work. Just a big long list of manual things. I didn't want to learn how to use a tool to do it. And so as I was getting ready to boot, I'm just like staring like at my MacBook screen. And sure enough, I got it to boot up. And I was quite happy. I'm like, oh, hey, a grub screen. oh, hey, look, there's systemd. That's good. And there's a login prompt. Like, cool. I was like super like happy, and like I was, oh my goodness, I was like celebrating. I was like so relieved that this worked the first try. The first try to get this whole thing working. I was super excited. So I'm going to end this with a little bit of pictures. This is kind of embarrassing, but I have to show everyone. This is my horrible lab. This is where it all happened. You can see my horrible wires and cables everywhere. So it's a mess, right? And my poor P550, it's got no case, and everything's in a horrible place. There's my Vision 5s with my fans, and then my big boy box. Of course, it's the most cleanest thing out of everything, right? Your lab is only as clean as the last big thing you built, which was that last picture. So for the future, right now we're trying to get a new build system built. We're kind of falling behind on that. Just life gets in the way. We want to support more RISC-V boards, and we're planning on getting off of GitLab into ForgeJo. And we also want to get some bootc images, but we're trying to get people to help us on that. Of course, more vendor kernels to support more boards, which is what the alternative architectures people are working on. Additional hardware to hopefully enable the future of Rocky Linux, especially on this architecture, right? So send help. So if you're interested in helping us maintain RISC-V, I encourage you to join Mattermost. We have the AltArch channel that dedicates their time to stuff like this. And also helping the Fedora project and the CentOS Stream folks do it is also great, right? Because it'll help them help us, and it'll be a nice constant positive loop, right? And that's it. Appreciate y'all. Thank you all for joining.
Yeah, so the reason I sent you those couple links about Live Bootstrap and Stage 0 was because they literally start from just a little seed of hex, but everything after that is comprehensible source code.
Okay.
You know, comprehensible scare quotes.
Right, yeah.
You know. So I was wondering if you went all the way there, or if you cross-compiled from another architecture for GCC.
No, so thankfully I already had a Fedora repository that gave me GCC, that gave me that stuff already. So everything was already like native. So like we were already using, what do they call it, like stage 1 or stage 2 at that point. We were kind of we kind of piggybacked on what the Fedora folks were already doing, right? So we thankfully we didn't have to do any cross compiling or any of that fun stuff. But of course it didn't make it. Yeah, it didn't. Of course, I would imagine cross compiling. I guess I'd have to experiment if I was bored. Maybe cross compiling may have like sped up a couple of things, but I have no idea unless I like
right.
Because like my whole thing was like, oh hey, I already have this native architecture from the Fedora folks. Okay, I'll just rely off of that, and it actually simplified some things, but it also brought in its own set of brought up its own set of problems, unfortunately. But
I see.
And a lot of those problems actually start with, like, if you're ever curious, like, it's kind of hard to find it, but like if you go and look at the compilation options that Fedora uses as opposed to like CentOS Stream or whatever, right? There is quite a divergence between what those two do, right? And so sometimes, like, if you're bootstrapping off of Fedora, which is what we essentially did for this, and then just kind of rebuilt everything on top, you end up running into similar situations like we did with LLVM, where like, oh hey, all these like flags are turned on, right? But like I don't want to have them all turned on, but for some reason, because Fedora already had them on, everything defaulted to on. And so it's like it becomes like a cat and mouse game of trying to find, okay, what do I need to do to get it to compile with these new options that Fedora doesn't use so that it plays nice, right? So sometimes we have to like play that game because I know the Red Hat folks, you know, they'll turn things off or on depending on what it is,
Right.
and then they'll also turn some very specific things on that is at odds with what the Fedora project does when they compile things. So it's always it makes things interesting, especially when you're like, well, why the heck did this fail? This shouldn't have failed. And then it turns out it's something dumb, like with the LLVM stuff, right? And it's like, okay, how do I reconcile this without spending 10 days on it? So, which is basically what I did, right?
Yeah. Man, that's I can't imagine having my internet just cutting out because I like, you know, set up my internet in such a way that
Yeah,
you know what I mean?
Yeah, because like I'm letting GCC build, and it's like what in the heck? Like, why am I all of a sudden? Yeah, I don't want to stop. I'm already 2 days in. Like I gotta wait for this thing to get done, and I was glad I let it get all the way through, but it was just so painful. I will say this though, after I had gotten GCC done the first time, the amount of time the next one took, it ended up I don't know, I couldn't figure out why, but the next time I had to do it, the amount it reduced by a day. And then as the bootstrapping continued and I had to keep rebuilding stuff or whatever, I eventually got it down to 4.5 days, which is pretty good. It's a lot better than the 7 days I was waiting on stuff, right?
Right.
But still, but thankfully now if I ever have to do that, which is not very often, my network is set up in such a way it won't kill me anymore. It was horrible. Like imagine watching like Netflix or something and then just everything coming to a halt and you're just like, bro, why? It happened many times.
For telling me, giving me a little insight into the process. Yeah, it's very interesting stuff. I love the idea of bootstrapping. Yeah, and it's super important. Anyways, I gotta head to the next talk.
All righty, and I appreciate the questions and appreciate you coming by.